Hey everyone, and welcome to this explainer. Today, we're diving headfirst into a challenge that literally everyone deploying generative AI faces. We're talking about why your large language model outputs might be falling short, and more importantly, exactly how we're going to fix them. If you've ever felt like you're just, wrestling with an AI to get it to follow even basic instructions, you are absolutely in the right place.
So why do AI outputs actually fail? I mean, we all know that whiplash, right? You get these brilliant, mind-blowing insights from an LLM one minute, and then completely hallucinated, unhelpful nonsense the very next. In an enterprise environment where accuracy is your literal currency, that kind of inconsistency is just incredibly frustrating. You really can't build a reliable automated workflow if the core engine powering the whole thing just decides to go off script every third request.
But here's the truth. The model itself usually isn't to blame. The real culprit? It's an unoptimized prompt. The source material from IBM we're looking at today highlights a pretty stark reality. Even microscopic, tiny tweaks to your prompt dictate massive differences in relevance, factual accuracy, and, crucially for your budget, API token costs. We're not just talking about coaxing a slightly better answer out of the system. We're talking about structural changes that directly impact the bottom line of your operations. It's a real game changer.
All right, here's our roadmap for how we're going to move from basic drafts to data-driven refinement. We'll cover the AI prompt problem, defining prompt optimization, engineering versus optimization, strategies and pitfalls, real-world use cases, and finally, the future of prompts. Let's jump in.
Starting with number one, the AI prompt problem and the hidden cost of generic inputs. So that massive number one right there, that represents your first iteration. And listen, without deliberate refinement, your first draft is honestly toxic to a production environment. It wastes computational tokens, it spikes latency, all because the model is burning massive amounts of compute power just trying to parse your ambiguous instructions. It totally lacks the specific context needed for your domain. Relying on draft number one is kind of like handing a vague sticky note to a brand new intern and just hoping they return with a masterpiece. You're leaving your AI's performance entirely up to chance, which for sure translates to wasted time and skyrocketing computing costs. Moving on to part two, defining prompt optimization and how we move way beyond the basics. So what does this actually entail? Well, prompt optimization is the iterative process of refining the structure, content, and clarity of an existing prompt to consistently enhance LLM responses. It sits right at the intersection of prompt engineering, relentless iteration, and strict task alignment. And it's super vital to understand. Actually, let me emphasize this. This is not a creative writing exercise where you're just fishing for magic words. It's a systematic, almost mathematical approach to unlocking reliable, repeatable outcomes from your models so they behave predictably every single time they're called. Okay, section 3, engineering versus optimization. These are two very distinct phases. Now, a lot of developers tend to conflate these two concepts, but there is a hard line between them, and understanding this distinction completely changes how you approach AI development. Prompt engineering is your 0 to 1 phase. It's designing a prompt structure from scratch, maybe throwing in basic examples and formats just to get the model working and prove the task is even possible. Optimization, on the other hand, is what happens next. It's the rigorous tuning of that original prompt using iterative testing and hard evaluation metrics. Think of engineering as building the car from scratch just so it can roll down the street, while optimization is plugging it into the diagnostic machine to tune the engine for maximum horsepower and fuel efficiency. And to tune that engine, you absolutely have to rely on a continuous optimization loop. Step 1 is benchmarking your baseline prompt so you have a concrete, measurable starting score. Step 2, you evaluate the output systematically, using either automated metrics or rigorous human judgment. Step 3, you adjust for clarity, structure, and specificity based on exactly where the model failed. And finally, step 4, you test it against a broad representative dataset to prove it actually scales beyond just a few lucky examples. You really shouldn't deploy to production until you've successfully run through this exact loop. Let's move into part 4, strategies and pitfalls. These are the best practices for getting maximum ROI. Here are the heavy-hitting strategies straight from the IBM research. A massive standout is CFCOPIO. That's Content Format Integrated Optimization. Research actually proves that jointly optimizing what you say and how you format it yields exponentially better results than just tweaking the text alone. Then there's metaprompting, which is a completely fascinating technique. It's basically putting the AI in front of a mirror and telling it to critique and rewrite its own prompt based on a set of rules. Combine that with few-shot examples and chain-of-thought reasoning, and you literally force the model to show its work step by step. This completely wipes out lazy logic jumps and gives you a highly transparent reasoning process. But to succeed here, you really have to dodge a few traps. Being too vague is an obvious one, but a much more subtle killer is overloading your prompt with too many instructions at once. Doing this literally fractures the model's attention mechanism, causing it to just randomly ignore parts of your request. Inconsistent formatting? Yeah, that will also completely derail your outputs. But the absolute cardinal sin? Skipping the iteration phase entirely. If you aren't testing your variations against hard metrics, you aren't optimizing. You're just guessing and crossing your fingers.
To stop guessing, enterprise teams are deploying some seriously specialized tools. Two major players highlighted in our sources are PromptLayer and Humanloop. PromptLayer acts exactly like GitHub for your prompts, giving you robust version control, latency tracking, and token monitoring over time, so you can see exactly how a tiny prompt change affects your actual bill. Humanloop leans heavily into feedback-driven tuning, using real human data to guide the model's behavior. These aren't just fancy dashboards, guys. They are what make that optimization loop we just discussed traceable and technically robust for your entire team.
All right, Section 5, Real-World Use Cases. This is where the theories meet reality. Let's look at how this plays out in the wild. Take customer support automation. The impact here is literally night and day. By using optimized prompts that are strictly tied to your internal policies, you drastically reduce AI hallucinations, which is absolutely crucial for protecting your brand's trust. But just as importantly, optimization acts like a scalpel, cutting out all the input fluff. Less fluff means fewer tokens sent to the API, which translates to faster resolution times for significantly less money when you run it at scale. Now, for data analysis and reporting, accuracy is obviously mandatory. Utilizing an optimized chain-of-thought strategy guarantees accurate trend extraction from massive data sets. By forcing the model to process a data table step by step through a meticulously tuned prompt, you completely prevent the LLM from getting dizzy and hallucinating when it's staring down massive matrices of numbers. The model explains its math, ensuring your reports are just rock solid. And for legal and compliance teams, the stakes couldn't be higher. Techniques like metaprompting and few-shot tuning are used to force absolute formatting consistency when summarizing highly sensitive legal contracts and audits. An optimized prompt acts as an ironclad guardrail, so the AI doesn't, accidentally invent a liability clause or drop an important date. It ensures the output is purely factual and perfectly structured for whatever automated downstream system needs to process it next. Finally, Section 6, the future of prompts. The big shift to automated refinement. This quote perfectly captures the horizon line. As the IBM research notes, we are rapidly moving away from humans just manually tweaking text in a sandbox. Very soon, AI systems are going to use techniques like reinforcement learning, basically learning directly from your thumbs up or thumbs down feedback, to autonomously rewrite their own prompts. These models will evaluate their success rates overnight, distill the best instructions, and dynamically adjust their inputs without any human intervention. The era of the static prompt is essentially dead. A living, adaptive interface is the true future of generative AI. So, what does this all mean for us? The tools, frameworks, and data-driven methods exist right now to take your AI outputs from being inconsistent and expensive to laser-accurate and highly efficient. The only question left is, are you going to keep treating your AI like a slot machine with first-draft guesses, or will you start optimizing to actually engineer your own success? Thanks so much for joining me on this explainer, and hey, happy optimizing!